Good afternoon. Sorry I'm out again, guys, and then I also want to apologize. It looks like my video didn't play yesterday. I'm hoping that I can fix it before you guys are done today, and that way you can watch it. Otherwise, if you could watch it over the weekend, that'd be great. I was also hoping, since a couple of you have had geometry before, it's a pretty simple concept, so they should have been able to help you with it. If not, why don't you guys try and, or I can try and incorporate some of that today. Okay, so your homework tonight is going to be Inscribed Angles worksheet, and I'll expect both those worksheets to be done on Monday. So let's get started. So today we're going to talk about an inscribed angle. Yesterday we talked about a central angle. And the central angle, the vertex of the angle is at the center. That's why we call it the central angle. And then we also found out yesterday that the central angle also has an intercepted arc. The intercepted arc has a measure that is equal to the central angle. So the measure of the intercepted arc is also 60 degrees. We also talked yesterday about minor arcs and major arcs. So this would be a minor arc, it's less than 180 degrees, and the major arc of this particular angle, the major arc, would be A, B, C, written like this, and the measure of the minor arc plus the measure of the major arc together are going to equal 360 degrees. And that's basically enough information to do that worksheet from yesterday. Okay, so an inscribed angle is defined as an angle formed by two chords. So here's a chord. I'll change my color here. Here's a chord, and here's a chord. So an inscribed angle is an angle formed by two chords in a circle which have a common endpoint. See how their common endpoint is at B? This common endpoint forms the vertex of the inscribed angle. And it also has to be on the circle. And we're going to look at that, what it looks like to not be an inscribed angle in a second here. The other two endpoints define what we call an intercepted arc on the circle. So this would be my intercepted arc. So it has the same intercepted arc as the central angle is. But do you notice that it's half the size? Which kind of makes sense, because it's kind of like taking the angle and stretching it across the entire circle. This is halfway across the circle. This is all the way across the circle. Okay, so let's look at this. So I've got two different angles here. I've got angle ABC, right here, angle ABC, which is intercepted. The measure of angle ABC is 27 degrees. Then I have an intercepted arc right here, and my intercepted arc has to be twice the size of the intercepted angle. So let's write that as, let's see, so the measure of angle ABC is going to be half the measure of arc AC. Let's see if that's true. What is the measure of angle ABC? Well, I wrote it right here. It's 27 equals half the measure of arc AC. The measure of arc AC is 54. Well, half of 54 is 27. So we're correct. But what's interesting here is there's another angle here. Let's see, let's change the color to pink. There's another angle here. The measure of angle ADC is also going to be half the measure of arc AC. So it doesn't matter. I can have any inscribed angle inside of this circle. If they share an intercepted arc, they're going to be congruent. So the measure of angle ADC is going to be half of the measure of arc AC, which is 54, which is 27. So that angle is 27 degrees as well. All right, I'm going to go ahead and highlight different arcs in here. Sorry, different angles in here. So here's one. There's an intercepted angle. Here's another intercepted angle. And this one right here would be a central angle. And it would be twice as big as this one. And twice as big as this one. Okay, let's work with it. Oh, first I want you to write down your answer bank. So go ahead and pause the video and write down all the answers on your homework sheet. We're going to do a lot of these right now, though. Okay, so let's start with number 1. State if each angle is an inscribed angle. If it is, name the angle and the intercepted arc. So let's look at this one. That vertex doesn't go all the way out to the circle. So this would be a no. What's the next one? Number 2. Let's see. X, V, W. The vertex is on the circle. So I would say yes. My angle is X, V, W. Or W, V, X. Doesn't really matter. And my arc would be X, W. That would be my minor arc, because it's less than 180 degrees. Look at the next one, number 3. Is this an intercepted angle? I'm sorry, I keep thinking intercepted, inscribed. Sorry, is this an inscribed angle? No. This is a central angle. Hopefully you guys caught that I kept saying intercepted instead of inscribed. Intercepted arc is right here. Inscribed angle would be if it went all the way across. Sorry about that. Okay, I'm going to leave number 4 for you guys to do. Let's do number 5. Find the measure of the arc or angle indicated. So I'm looking for this angle right here. I'm looking for the measure of angle HGF. HGF, and we'll highlight it. HGF is going to be equal to half of the intercepted arc. So half of HF. The measure of HF. Okay, so the measure of HF is 84. And half of 84 is 42. So this angle is 42 degrees. Pretty straightforward, right? Okay, let's do number 6. Lots of intercepted angles, inscribed angles in here. The one I want to know is this one right here. X, F, D. Sorry, not very straight. D, F, X. I like that better. So the measure of angle D, F, X is going to be half of the measure of D, X. arc dx. Well, I know the measure of arc dx. Measure of arc dx is 110. So half of 110 is 55 degrees. So this will be 55 degrees. All right, moving on. I'll do number 7 for you. So this time we're going to find the measure of this major arc. So I'm going to highlight it. The measure of VWX. Well, we know that the measure of major arc VWX has to be twice as big as that inscribed angle. We'll call it VPX. Measure of angle VPX. Well, I know the measure of angle VPX. It happens to be 110. So the measure of the arc would be 220 degrees. Okay, I'm going to leave number 8 for you guys to do. I'll do number 9. So number 9, oh, it's right here. I'm like, what are we looking for? Okay, so I'm looking for the measure of arc LR. Well, they gave us the measure of the angle LRP. They gave us that, but it has a different arc, intercepted arc. It has LP. But notice as I combine the two arcs, they make half of my circle. And I know half of my circle is 180 degrees. So let's write that. So the measure of arc LP plus the measure of arc LR equals 180 degrees. Well, I know I have more information here. I know I have the measure of LRP is going to be half of this measure. So let's see how I want to write this. LP is twice as big. So the measure of arc LP, I'm sorry, I should just substitute. That would be better. We're going to substitute this one for twice as big as the measure of angle LRP. LRP plus, I still have the measure of LR equals 180 degrees. Well, I already know the measure of LRP, it's 36. So 2 times 36 plus the measure of arc LR equals 180. 2 36s are 72 plus the measure of LR. And you don't have to be as formal as this when you do this. I could simply say, okay, this is 72. I know all the way around here is 180. So 180 minus 72 is going to give me 108. That's fully reasonable. I can see exactly what you're doing. That's showing your work. I'm just doing it the formal way. So now if I subtract 72 from both sides, I'm going to get the measure of arc LR equals 108. So whether you reason with the picture or whether you reason algebraically, you're going to get the same answer. Okay, let's try one solving for x. I'm going to leave number 10 for you to do. Let's do number 11 together. All right, so if I'm looking for x and I'm noticing that I'm getting this arc, and I've got this arc, and I've got this arc. So I have arcs all the way around the circle, and I happen to know that the degrees around a circle is 360 degrees. So I'm going to say the measure, let's start here, LM. The measure of arc LM plus the measure of arc MN plus the measure of arc NL all equal 360 degrees. So I'm going to substitute. The measure of LM is 10x plus 10. The measure of MN is 17x minus 10. And the measure of NL is 90 degrees. Alright, well, 10x's and 17x's is 27x's. Positive 10 and a negative 10 cancel each other out. So now I have 27x plus 90 equals 360. I'm going to go ahead and subtract 90 from both sides. And hopefully, from transformations, you guys remember, oh, I'm back on black. Remember that 360 minus, if I was here and I went to here, minus 90 would be 270. Or you could just do the math. Okay, so if I divide both of these by 27, we're going to get 10. Or if I just think 27 times what makes 270? So x equals 10. And if I substitute that back in, for all of these, let's see what happens. 10 times 10 plus 10. Well, 10 times 10 is 100, plus 10 is 110. I should have written it here. 110. And down here, 17 times 10 minus 10. 17 times 10 is 170, minus 10 is 160. So 160 plus 110 is 270. 270 plus 90 is 360. So we know we're correct. Should make that a better check mark. All right, I'm going to do one more with you. Number 15. So number 15, I've got an inscribed angle here. An inscribed angle is half of the measure of the intercepted arc. So I'm going to go ahead and, well, I'll take care of that in a second. So I'm looking for x, and it gives me this. I know that from here to here is 180 degrees. So first I'm going to write that. The measure of arc TR plus the measure of arc RS equals 180. I know that the measure of RS is going to be twice as big as the measure of angle RTS. So let's start putting together some of this information. So the measure of TR, or arc TR, is 11x minus 9 plus 2 of the measures of RTS would be 2 times 5x equals 180. Now for those of you that like it more visually, like I do, 5x over here would be 10x's. Then I would just add them up and equal it to 180 degrees. So I have 11x minus 9 plus 10x equals 180. Then I have 21x's minus 9 equals 180. Add 9 to both sides. And you get 21x's equals 189, and x equals 9. Okay, so why don't you guys finish up together and get your homework done. Have a great weekend.